Hello there, Mr. Chen here for Algebra 1. Please grab your note takers and turn to page 175. We are about to do 8-3, quadratic functions in standard form. In the previous section, we talked about the vertex form. I want to briefly mention that before we do this one. A lot of the parts are the same. Vertex form was a times x minus h squared plus k. To find the vertex, you looked at the h and k value. The axis of symmetry was simply x equals h. So that's interesting from the last section. This section, the form that it's given to us is ax squared plus bx plus c. This is called standard form. So we'll talk about that more so later. But for now, let's go ahead and take a look at this explore and reason here. Let's zoom in a little bit. Three functions of the form f of x equals ax squared plus bx are graphed for a equals 2 and different values of b. Notice the b value in this form are minus 2x, minus 4x, and minus 6x. That seems to create different parabolas, and they seem to cross the x-axis at different points. I'm going to go ahead and highlight those points right now along the x-axis. Those, of course, are called x-intercepts. Okay. So note that they did mention that the leading coefficient is 2. So the point is this: the numbers do affect how the graph crosses the x-axis. Let's go ahead and answer some questions here. What do the graphs have in common? In what ways do they differ? Well, they're all parabolas, which means they have the same shape. Great. They all open up. And simply because a is greater than 0 or positive, the leading coefficient. And one of the intercepts is at the origin, meaning 0, 0. Question: how are these different? They definitely have different. Let's take a look up here again. Oh yeah, you guys see it too? They have different vertices. Interesting. All right, let's answer some more questions about those three graphs here. What do you notice about the x-intercepts of each graph? What do you notice about the y-intercepts of each graph? So we've already highlighted the x-intercepts right there, 0, 0, 2, 0, 4, 0, 6, 0. And the y-intercept, where it crosses the y-axis, seems to be the same at 0. Interesting. Let's jot that down. The x-intercepts happen to be at 0, 2, and 4. The y-intercept, oh, there are actually 4 x-intercepts. My bad. The y-intercepts are all the same, and they happen to be at 0 on the y-axis. Next question, look at the ratio b over a for each function and compare it to its graph. What do you notice? Now b over a as a ratio, meaning division, is basically b of x over ax squared. So this ratio, the x's would cancel one of them. Kind of interesting. That's what I noticed. We're going to skip this question right here and move on to the next page. Let's do that. So some of you are wondering, hey, is this just like the last section with the vertex form? The answer is kind of no, but we're looking for the same parts. When that is the case, especially for example 1, this is called standard form here. Ax squared plus bx plus c. Let's write that down. When you're presented with an equation of a quadratic in standard form, there are different things to look for and the order. So these are the parts. Draw some axes here, off to the left. We're going to arbitrarily draw a genetic parabola. And let's remind ourselves what all these parts are. Now, interestingly enough, I'm just going to tell you right now, when your quadratics in standard form, the y-intercept you can find very, very quick. This dot that I'm highlighting right there is called the y-intercept, and that's when x equals 0. The y-intercept is when x equal to 0. Write that down. And if you stare at the problem in this particular case, when x equal to 0, I'm just going to show it to you algebraically how this works. What's left when you set x equal to 0? So here, I'll set x equal to 0, which means 0 goes here and 0 goes there. 0 times anything is 0. It goes away. That goes to 0. That goes to 0. What's the only thing that's left? C. Ladies and gentlemen, C is the y-intercept. The constant by itself is the y-intercept in standard form. That's really cool. So C is the y-intercept. They'll tell you where the parabola crosses the y-axis, and that's the key. So on the graph over here, C is your y-intercept when x equal to 0. Yay. That's something you don't see in the vertex form. This is exclusively for the standard form. Now, interestingly enough, I'm going to go ahead and just demonstrate what would happen. With 3 examples on the calculator. Here are the problems themselves. Negative 2x squared plus 4x minus 3 is the first one. Negative 2x squared plus 4x minus 1 is the second one. And then finally, negative 2x squared plus 4x plus 5. And what would happen when you graph this is that you'll get an upside down parabola, leading coefficient's negative, and this particular one on the left will cross the y-axis at -3. The second one will cross through -1, right? And the third one will cross through +5. That's just a given when x equal to 0, right? When you set x equal to 0, everything else goes away except the constant by itself. It's pretty easy there. Yay. So I'm just finishing up by drawing the pictures of each of these particular parabolas, okay? That's how straightforward that is. Let me know if you have any questions. Let's move on to number 2. Let's move to the left here and make a laundry list of things to look for when it comes to parabolas in standard form. Yay. So let's remind ourselves really quick because it's off the screen. I'm going to write it again. F of x equals 2ax squared plus bx plus c. When you're given standard form, here is a process of uncovering all the parts of the parabola so you can graph it properly. First thing you want to do is identify the y-intercept, right? This is when we set x equal to 0, technically. When you do that, it's just the c value. The c value, ladies and gentlemen, is your y-intercept, the number by itself. Step 2, look for the axis of symmetry. This is where the parabola is cut in half. Axis of symmetry is a simple formula. You're going to have to trust me on this. X equals negative b over 2a is the formula. Now, b and a are, of course, referring to the original quadratic formula. You just pluck those coefficients in front of that problem. Pretty straightforward there. Third thing you want to find, so you can graph the whole thing in the first place, is the vertex. Okay, this is not vertex form. This is just finding the vertex from the standard form. Here's the formula. It's a coordinate point, x comma y. What you want to do is you want to put negative b over 2a right here, plug it into the equation, and solve and simplify that particular equation. So here, to find this part, substitute negative b over 2a into the equation. Yay! Those are the steps when it comes to quadratics in standard form. This will give you a leg up when it comes to graphing. It is not easy to try to graph this by hand without the parts that are staring at you, okay? All right, let's try 2a. Graph each function where the y-intercept, axis of symmetry, and the vertex of each function. So we talked about the laundry list earlier. Here it is. I have to zoom out a little bit. But anyway, let's go and identify the y-intercept. Oh, there it is, yay, 4. And by the way, I'm looking at this function. I'm going to guesstimate how we're going to situate our axes. Draw your vertical axis right down the middle. Looks like this one's just above the x-axis, so give yourself a little room in the first and second quadrant, and draw your axes accordingly. There it is. But the first step was finding the y-intercept. Let's identify that. Yay. The y-intercept, of course, is 4, right there. Let's go into the y-axis and put a dot at 4. If you label it, that'd be awesome too. Second step, find the axis of symmetry. The formula is very straightforward. X equals negative b over 2a. Look up here in the standard form and identify those parts. A is 1. See, it's not there, it's just invisible. B equals 2, and C equals 4. Okay? Plug that into the equation, negative b over 2a, and we'll get an answer. Yay. So b in this case is 2, and 4 in this case is 4. Did I say 4? Whoops. I meant A. I put in C on accident. Sorry about that. A is 1. So negative 2 over 2 is negative 1. Very nice. That's your axis of symmetry. It's a formula. X equals negative 1. It's literally a vertical line at negative 1. Oh, okay. Very good. Somewhere on that axis of symmetry lies the vertex. We've already got half the answer for the vertex, so all we have to do now is find the other half. Right? We just got -1. We're going to plug that into the function. In this case, f of -1 equals to -1 squared plus 2 times -1 plus 4. So let's plug that -1 into the problem. Please be careful. This doesn't mean f times -1. That just means you're plugging in an independent variable x, which happens to be -1, into this equation. Let's simplify it. -1 squared is +1. 2 times -1 is -2. And then finally 4. 1 minus 2 is -1. Plus 4 is 3. Ding, 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 ding. Therefore, my vertex is at the number I just plugged in, -1, and I spit out the number 3. So -1, 3 is right here. Label it. Oh, that's kind of interesting. We have a red dot on the y-intercept. We can just call that connected. That's half of the parabola right there. Whoa. And the other half is a mirror image on the other side of the axis of symmetry. So I'll put a dot here to represent that. And ladies and gentlemen, congratulations. You just draw your first standard form quadratic. Yay. What other questions to ask for? Axis of symmetry, vertex of each function. Okay. I do want to mention the vertex happens to be the minimum because it's the lowest point. It's kind of good to just think about all the little intricacies about your graphs, okay? I'm not a fan of letter B. Those are ugly numbers. I changed it last year. So we'll do the same here, okay? Let's try 2x squared plus 4x plus 3, right? A is 2, B is 4, and C is 3. All right, let's go ahead and give ourselves a little room. As you can guess, we are going to stick with the first and second quadrants based off of the information given to us. All right, first things first, let's find the y-intercept by inspection. Oh, there it is, +3, woohoo. So on the y-axis, go to 3, put a big old dot there and label it 3 so you don't lose track of those. Second step, axis of symmetry. So when I look at my other material, I guess, I'm sorry, axis of symmetry, I misspoke there for a moment. -b over 2a. Let's plug in the values here. B, of course, is 4. A up there is 2. Interesting. Clean that up. And you'll get -4 over 4, which equals to -1. Ding, 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 ding. Ladies and gentlemen, that is your equation. X equals -1. Let's do that. Oh, that's the same as the last problem. Very interesting. Put a vertical dotted line there, label it AOS. It's very helpful. And then finally, the last question here is find the vertex. Well, we've already figured out the X value of the vertex, right, everybody? -1, we just found. But we don't know what the heck the Y value is. It's very, very difficult. All you have to do, though, is plug in -1 into the equation. Dun, 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 dun. And the equation is 2x squared plus 4x plus 3. We are putting in the -1. Please understand this is function notation. F of -1 means you're plugging in -1 and you will spit out an answer. Watch what you're doing here. Don't do 2 times -1, that's bad. -1 squared is +1 times 2 is 2. The middle term, plus 4 times negative 1 is negative 4, and then plus 3. So cleaning this up, 2 minus 4 is negative 2, plus 3 is positive 1. Yay, there it is. So therefore, my vertex is at negative 1, 1. Let's put that dot right. Oh, there it is. There's my vertex. Yay. And it's kind of a skinny feller. Go ahead and finish it off. Whoa. And you know parabolas have symmetry. Look at that red dot. Throw an artificial red dot over there, and whoa, we've got ourselves an answer. Very good. Let's go to the next page. How are we doing out there? Yeah, we'll skip this habits of mind. All right, switch to the next page. All right, here we go. Number 3. Ooh. Let's remind ourselves. AX squared plus BX plus C. We're going to go ahead and just basically come up with some characteristics of this particular graph. We're not going to compare, so I'm going to skip that part. But I'd like to take a look at the parabola that's been given to us. Sometimes graphs are hard to interpret. And let's try to figure out what the standard form will maybe look like. Obviously, this is a parabola that opens upside down. In this case, I'm going to go ahead and put a dot right there. That's the vertex, of course. The vertex to me definitely looks like 3, 0. I'm just identifying parts right now. That parabola is cut in half. That's the axis of symmetry. Let's write that down, right? It's a vertical line at x equals 3, just by visual inspecting it. Another thing we notice that this particular parabola opens down, which basically says that A is negative. Very good. And because this parabola is opening down, the vertex is a maximum. Just a lot of little things, okay? All right. And finally, one last thing they might ask is the y-intercept. Looks like negative 2.3, negative 2.2-ish kind of a thing. We'll call it negative 2.4-ish, okay? We don't know exactly. All right. There's a habits of mind in example 3. How can you tell from the equation of both of the function f that the function has a maximum? Well, we just mentioned that earlier because it opens down. How can you tell from the table that the function, okay, forget about the table there. Hey, let's move on to the next problem, number 4. Now this is interesting. They throw this type of a question into this section. I don't know why, but this particular problem is in vertex form. And of course, just a quick reminder, a times x minus h squared plus k. Find the ball's initial and maximum heights. Now this is kind of interesting. The vertex, I don't know why they put it into the section, is at hk. And in this case, h is, let's look up here, is positive 1, and k is 6.25. For a real-world problem, the 1 represents 1 second, whereas the 6.25 represents the feet. That's all. All right, you guys ready for the last page? We're going to do 2 problems on the last page out of the 4 that's left. It's basically just following formulas. Here we go. Not too bad. Graph each function. For each, identify the axis of symmetry, the y-intercept, and the coordinates of the vertex. So those are the 3 main things for the standard form that we've been working on. Great. I like to find the y-intercept first. Let's label that. The y-intercept is the constant by itself. Yay. So in this case, it's -1. Awesome. I'm not even going to graph it yet. I want to just kind of eyeball it and then adjust the axes accordingly. Speaking of axes, the axis of symmetry is next. Let's split the parabola in half. The formula is -b/2a. Oh, let's identify a, b, and c here. A is 2, b is 8. That will help me in my formula for -b/2a. b, of course, is 8. And my a value is 2. Let's clean that up. This equals -8/4. That reduces to -2. There it is. Yay. There is my axis of symmetry. Oh, interesting. -2. And then finally, I want to find out what my vertex is. We've just found half the battle. -2 goes right there. And we just have to figure out what the y value is by plugging in -2 into the function. Kind of running out of space a little bit, so I'm going to do that over here off to the side here. I want to find f of -2 from the original function. So I'm just writing out the template here. Oh, I meant to put a blank right there. Sorry about that. 8x -1. We're plugging in -2. Remember, that's function notation. You don't have to worry about that. Clean up this part. Be very careful. Do the powers first. -2 squared is +4. Watch that. 8 times -2 is -16. Keep going. And that equals -9. That's the y value of the vertex. Yay. Sweet. So let's go ahead and try to plot this. Keep in mind, we've got an axis of symmetry of -2, on y-intercept of -1, and my vertex is in the 3rd quadrant, so let's give ourselves a little room here. Let's do this. Let's draw a vertical axis right here. And for my vertex, I need plenty of room as possible because it goes to -2, -9. All right, so y-intercept is -1. Great, put a dot there. Axis of symmetry is -2. Awesome. And finally, the vertex is at -2, -9. So it's all the way down there. -2, -9. That's my vertex. And I just connect the vertex to what? The red dot. That's all you have to do. Very easy, right? Whoa, skinny fellow. And to kind of eyeball this other half, see what I'm doing? This is 2 over there, that's 2 over there. I'm going to finish off the symmetry right like this. Yay. And there's your parabola opening right up. I'm actually going to skip number 6, but I do note that because your a value is negative, number 6, the parabola opens upside down. Okay, I just want to point that out. But the process is the same as number 5. Let's do one more. Let's do number 7. Interesting. Hey, my favorite thing to do first for the standard form is to find the y-intercept. In this case, -5. Awesome. We'll come back to that in a second. Axis of symmetry is next. X equals -b/2a. B, let's find all these. A is -3, B is -6, C, of course, is -5. But in this case, we've got to put in the numbers. So B, -6. Oh, interesting. Over 2 times -3. If we clean that up, we will get +6 over -6. Thank goodness, that's easy to reduce there. That's -1 is my axis of symmetry. Yay. Finally, the vertex. Take the axis of symmetry you just got, put it into that spot, and we're just trying to figure out what the heck the y value is, right? Let's plug in -1 into the function right now. I'm not actually putting the number in first. I like to do this and then worry about it later. We are putting in, ladies and gentlemen, -1 right there, and right there. Literally, the function value, I mean the y value, when you're plugging in 1 is equal to -3 times that squared minus 6 times that minus 5. We're putting in, what are we putting in? -1. Whoa, that was weird. Did I just do that twice? I'm a little confused. It's getting late. I'm kind of losing it right now. All right, -1 squared is first, is +1. And -6 times -1 is +6. And minus 5. So that's going to be -3 plus 6 minus 5. That, ladies and gentlemen, is -2. Yay. So my vertex is -1, -2. It kind of seems like we're in the third quadrant again. So do this for me. Draw your x-axis a little higher than normal, and y goes right here. And that's going to plot all these points. Y-intercept is at -5, okay? There it is, -5, my y-intercept. The axis of symmetry is -1. Okay, it's a vertical line through -1, fine, let's throw that in. And then finally, the vertex is at -1, -2. Oh, interesting. It's an upside down parabola. Very cool. And we've got to finish off the other side of the symmetric parabola, 1 over to the other side from that red dot. And there it is. Well, thank you very much. If you have any questions, let me know. Follow the formulas. Have a good day. Bye-bye.